Hello guys, in this tutorial I am going to show you how to analyze a beam under point loading and UDL, uniformly distributed load. Let's do a random problem. Let's go to preferences, structural, click OK, preprocessor, element type, add a beam element, beam to node 188, click OK, close. There's no need for real constants for beams, so go to material properties, material models, structural linear elastic isotropic 2E5 0.3 as Young's modulus and Poisson ratio for steel. Close that and go to sections, beam, common section, pick a square subtype and assign B and H values, breadth and height. Close it. Go to modeling, create key points in active CS. First key point at 000, second key point at say 50 00, third key point at say 50 plus 50 100 00. Click OK. We have the key points right over here. Now go to lines, straight line, pick the nodes 1 and 2. Now pick the nodes 2 and 3. You will have two lines from the nodes 1 to 3. Now the modeling has been done. Now we need to mesh it. Go to meshing, size controls, manual size, lines, all lines. Let's say element edge is 10. The total length is 100, element edge is 10, so 100 by 10 you will have 10 components. Go to mesh, lines, tick box, click and drag a box to select all the elements. Okay, now it has been meshed. Meshing has been done. Now go to loads, define loads, apply, structural, displacement, click the key point 1 and arrest all degrees of freedom as it is fixed. Say it's fixed. Now let us assume a hinge over here at second node which allows rotation only about Z axis. So click second node, OK. Arrest every degree of freedom except rotation about Z axis. Click OK. Now the boundary conditions have been specified. Go to force to apply point load on key point. Pick the key point 2, 3 as you wish. Along y direction, let us say load of 3000 newtons. Okay, cancel because I want to show you how to do UDL instead of point loading, because both of them have the same procedure right from this point. So I'll just go to say pressure on beams. I'll pick the nodes 2 and 3 using the box type. From 2 and 3 all the elements using the box type. Click on box, click drag, select all the elements from node 2 to node 3. You will be able to apply. So the load key 1 is for pressure along Z direction. Load key 2 for pressure along Y. At node I, say there is 3000 newtons. At node J 3000 newtons too, because it's UDL. Click OK. You can see the UDL right over here. If you give different value at J node, it will become uniform variable load UVL. Now the loads have been given. Head on to solution, solve, current load step, click OK, close, close. Go to general post processor, plot results, deform shape, deform plus undeformed shape, click OK. You will see the deform shape right over here. Contour plot nodal solution for displacements along any component. Y or displacement vector sum, it doesn't matter because both are same, as x and z components are 0. Go to element solution for stresses and strains. But wait, because stresses and strains won't show up directly for beams, you need to define element table. So go to element table, define table, add stress. For stress, type in stress label as stress by sequence number ls 1. For stress, ls is the keyword and 1 is the element number. Click apply. For strain, click by sequence number, lepel is the keyword. Click 1 for element number 1. Apply. Click sfz, shear force along z by sequence number SMISC. Now you need to specify the codes. If you don't know the codes, just hit up the help button and search the element you want. In my case, it's beam 188. Click beam 188. At the bottom of this document, you will be able to find loads for different parameters. I mean codes for different parameters. For moment about Z and shear force about Z, there are codes being given. The codes have been given. You can just copy these codes. For shear force, the codes are 6 SFZ again. The other code is 19. Click apply. Now for moment about Z, bending moment about Z by sequence number SMISC, the code is 3 and 16. So click 3, apply. Bending moment about Z by sequence number 16, right? Yes, 16. Click OK. So you have stress, strain, shear force and bending moment here. Close this. Now go to plot results, contour plot, line element results, say stress for I and J and click OK. You will be able to see stress distribution. Now go to line element results, put strain for I and J, click OK. You will be able to see strain distribution. Similarly for shear force and bending moment too. Shear force distribution, because it's hinged at load 2, there is no distribution at 1 to 2. For bending moment, click OK. This is the bending moment distribution. So go to list results for documentation of results. Element solution for stresses and strains. Reaction solution for reaction forces. Click all structural forces. Click OK. So these are the reaction forces at nodes 1 and 2. So that's all about this tutorial, guys. Click the like button if you like it and subscribe for more videos. Thank you. Bye bye.